Problem 9.3 is a good summary of the whole idea of this chapter. So it's a good one for us to go over. What they do is they give us a quadratic. This thing here, y is 2x squared minus 2x minus 1. And then we look at finding the inverse function for it. One thing right away we know what the quadratic is. It's not going to be 1-to-1. So right away we know we're going to have different domains to operate under. So let's go over what that means. So part A says to graph it first. They say to graph it and then find the vertex, but it's like, no, you graph it by finding the vertex first. And remember, these graphs don't have to be really pretty. It's the idea that counts. So what we do is we find the vertex of that thing. So x is negative b over 2a. Negative b is 3. 2a is 4, so it's 3/4. And if that's 3/4, then y is 2 times 3/4 squared. This is going to be somewhat unfortunate. 3 times 3/4 minus 1. That'd be nice if it would have been, the vertex would have been 1 or something. So now we got to do some fraction work here. Oh well. Let's see, that's 9/16 times 2, which is 18/16, minus 9/4 minus 1. Let's change all that to, let's see, to 16ths, I guess. So that's 18/16 minus 9 times 2 is, no, we got to multiply this by 4, right? Yeah, sorry, the bottom by 4, top by 4, so it's minus 36/16. So 16th by 4, yep, that's right. Minus 1 is 16/16, which is, let's see, 18 minus 16 is 2/16. Minus 36 is minus 34/16. Let's see, those can be divided by 2. That's 17/8, which is 2, it's negative. Negative 2 1/8. All right, let's write that as a decimal, negative 2.125. Okay, so the vertex is x at negative 2.125. Or y is that. That's the y value. The x value is 3/4. So if we graph it, I'm just doing a quick little graph here. X is 3/4. Y is more than that, negative 2, so maybe somewhere down here. So somewhere down here is the vertex. It opens up because that's positive. It's a 2 there, so it's going to be a little bit narrower than normal. So, you know, you kind of draw it maybe a little bit narrow of a parabola, something like that. And that's all you got to do. Don't worry about finding the points and stuff. It's just the idea here that counts. So, clearly, this is a function, right? This is a perfectly good function because for every value of x, we have one value of y, right? If we do the vertical line test, which is what we've done in the past, it works. However, the inverse is not a function because x can be a function of y, or for every x is one y, but for every y, we do the horizontal line test. For every y, there are 2 x's. There's this x and that x. So if we do the inverse, it doesn't work. It has to work both ways. For every x, there's one y. For every y, there's one x for there to be an inverse. So this does not have an inverse. So what we have to do is break it up. We have to break it up like right at the vertex. And then if we only limit it to x's on this side, then it has an inverse because then, you know, that only goes through one side of it. Or we can do it the other side and it can have an inverse. But we can't do it for the whole thing. So we got to choose which x we want. They decided in part B here, B, they said, B explains why it doesn't have an inverse. So we already said that for part B because it doesn't pass the horizontal line test. So for part C, they say do it for x greater than or equal to the vertex. So x greater than or equal to a, they call the vertex, which is 3/4. So that is our domain. We're going to only do it for x greater than or equal to 3/4. Okay, that's our domain. So we might as well figure out the range of this thing. So this is the domain of the function, the domain of our function f of x. So the range of our function f of x, if we plug in 3/4, we know we get this, negative 2.125, and as x gets bigger, the y value goes to infinity. So right away we can write the range is as small as the vertex, the y values, right? The range is the y value of our function. It's as small as the vertex, which is negative 2.125, and I put a bracket there because it includes that. And then it goes all the way to infinity. The y, this thing probably goes up forever, right? So it goes all the way to infinity, and I'm going to put a closed bracket like that. So this is the range of f of x. So we already know what the domain and range are of the inverse function. They're the opposite. The range of f of x means it's the domain of f negative 1, the inverse of x, or y if we leave the y in there. It doesn't matter what variable we use, x or y. The way you solve it, you keep a y in it. So we can put y there. And then this one then is the range of the inverse function of y. And checking those things that it works is a really good way to check your algebra. Making sure that that actually is the case, that this would be the domain and that's the range. Now we could write this one in this notation too. X greater than or equal to 3/4 would be written like 3/4 comma infinity, right? So x goes all the way from 3/4 here, infinity that way, which makes sense. So this works or that works. I like this notation. I think it's easier to think about because it goes from here to here, but whatever. Okay, that's the domain and range of both the function and its inverse. And then they say to find the formula for the inverse function. That means solving for y. No, sorry, not solving for y, solving for x. X as a function of y, and that would be our inverse function. Here, y as a function of x is a function. Now we want x as a function of y is the inverse function. That's what this thing is, okay? So that's the algebra part. So we write this down, y equals 2x squared minus 3x minus 1. We want to solve for x. So I'm going to put the y over here, subtract y from both sides. Then we get 0 is 2x squared minus 3x minus 1 minus y. I like putting the 0 on the right, it just looks more normal. So I'm going to do that. So 2x squared minus 3x minus 1 plus y equals 0. All right, so minus 1 minus y is like minus 1 minus y. I'm going to write it like this because now we can use the quadratic formula to solve this. 1 plus y minus 1 plus y is our c. And then this is our b and that's our a. Right, so a is 2, b is negative 3, and c is negative 1 plus y. Or we could left it as minus 1 minus y, but I don't know, it just makes it kind of cleaner to do it like that. It doesn't really matter. Okay, now we use a quadratic formula to solve for x. So, as always, x is negative b, b is negative 3, so 3 plus or minus the square root of b squared, which is 9, minus 4 times a, which is 2, times c, which is negative 1 plus y. We got to be really careful of that negative in there. All divided by 2a, which is 4. All right. We have minus and a negative. Got to be really careful of those negatives there. Minus, negative. So I'm going to continue up here now. So 3/4, so it's 3/4. We want the plus because we want the positive side of x. So far, we haven't said here which side of we're just solving for the function, but we want the positive side, right? We want the bigger x's. So we know we're going to take the plus there. So it's 3/4 plus the square root of 9 plus, because that minus negative is plus, 8 times 1, so 9 plus 8, 8 times y, so plus 8y, and that's still divided by 4. Or finally, we can write that as 3/4 plus the square root of 9 plus 8, 17, 17 plus 8y divided by 4. Okay, that will be our new function. So we can call that x, this is f negative 1 of x. I ran out of room there to write it, but I can squeeze it in there. I can erase my little line here. This is f negative 1, barely read it, of y as a function of y because I have a y in it. So this is our inverse function. our inverse function f negative 1 of y is 3/4 plus square root, okay, that's bad too, I can write that thing there, equals 3/4 plus square root of 17 plus 8y over 4. Now, we check our answers. It's really easy to make mistakes in doing all this algebra, right? Quadratic formulas, lots of mistakes. Does this have a range of this? Is the range greater than 3/4? Yes, because this can it be 3/4, I guess? For this to be 0, when this is 0, it's 3/4. It's 3/4 plus a positive number. The smallest it can possibly be is 3/4, because it's 3/4 plus a positive number. And when y is negative 2.125, which is the range of y, right? The domain of this, so on the domain is negative 2.125. We plug that in. 8 times that is negative 17. And we get 0, which makes this 3/4. So when y is negative 2.125, then f negative 1 of y is 3/4, because this is 0. So that works. That gives us this, our range. And when y is infinity, we have a positive infinity inside the square root, then this gets infinitely big. So that also makes sense. So it goes from 3/4 to infinity. The range of this one, of our inverse, is the domain of the original function, greater than or equal to 3/4. So always check that, make sure that that works. In this case, it completely works, which is really cool. So now we have our inverse function. And then on the last part, they say, find the domain, find the formula for the inverse function, f negative 1 of y. For the other side of it, for x less than this one, right? For x less than negative 2.125. So all we gotta do for part D is exactly the same thing, but our new domain is x less than or equal to here. Right now we're doing the other side of our parabola. So we're doing the left side versus the right side. So you change that to less than or equal to, so x, and then the other big thing is here, when you do this math, you just take the negative. You just take the negative here instead of the positive, because we want the other side now. And then you just keep that negative, you do the same thing, and you should get something that checks, that makes sense, and check it to make sure it makes sense, because the domain and range can be slightly different. Instead of going from 3/4 to infinity, you go from 3/4 to negative infinity. Oh, and I should put that should be a parenthesis, right? You can't get to infinity. Whew, that was close. So 3/4 to negative infinity, the other way. So you put the negative infinity first to 3/4. And then find the range also. And the range is clear from this picture, right? It goes from here to infinity. Actually, the range is the same of the function. The domain is what's different. Domain from here to here, range from that number from negative 2.125 to infinity. I think I've said enough there. Okay, so I think you can work that out at the end. Okay, the overall ideas, okay, the important stuff here is when you have a function, to have an inverse, it has to pass the horizontal line test. Anything with squareds, any quadratic will never pass that test because it's got two things going up or down. And so you have to break it up, usually at the vertex. You don't have to, right? You could break it up here, but then this one wouldn't be a function. If you break it with the vertex, each side is a function that has an inverse. So if you're going to do inverses, you got to make sure it passes a horizontal line test. Otherwise, you're going to get something funny going on, like the plus or minus, right? It's like, wait, there's two options for the, you can only supposed to be one option to be a legitimate function. Yes. Okay, good. I hope that makes sense and you guys are becoming experts on inverse functions. Awesome.